Hello everyone, this is Shubham Chaudhary and I welcome you again in the new video of our YouTube channel. So today I will be discussing this LeetCode medium problem which was asked on 17th of February, and it is furthest building you can reach. So we have given an integer array heights representing the heights of buildings, some bricks and some ladders, and we need to start our journey from building 0 and move to the next building by possibly using bricks or ladders. So while moving from building I to building I plus 1, and it is a 0 indexed, so if the current building's height is greater than or equal to the next building's height, we do not need a ladder or bricks. And if the current building's height is less than the next building's height, then we can either use one ladder or height of I plus 1 minus height of I bricks. So, and we need to return the furthest building index that we can reach if we use the given ladders or bricks optimally. So here is the representation of what they are saying. Here they have used here they have used bricks and here they have used ladder. So we need to think of these 2 points. If the current building's height is greater than or equal to the next building's height, then we do not need any ladder or bricks. So here in this situation, current building height is greater than or equal to the next building, so it is simply going downwards. And if the current building's height is less than the next building's height, then we can use one ladder or height of I plus 1 minus height of I bricks. So we need to optimize this. So in the first example, heights array is this and bricks equals to 5, ladder equals to 1. So output is 4. 4 is the index that we can go farthest from 0 position. So starting at building 0, we can follow the steps. Go to the building 1 without using ladder nor bricks, since 4 is greater than equal to 2. Here 4 is greater than equal to 2. Then go to the buildings 2 using 5 bricks, because difference is 5. You must use either bricks or ladder because 2 is less than 7. And then go to the building 3 without using ladders nor bricks, since 7 is greater than equal to 6. Then go to the building 4 using only ladder. Then you must use either bricks or ladders because 6 is less than 9. So we are using it, and after that it is impossible to go beyond building 4 because we do not have any more bricks or ladders, because they only provided 5 bricks and 1 ladder. That's why. So we will return 4 here. And again, for example second, same as the above, and for example third, same as the above. So what should be the approach to solve this problem? Let's discuss. So first of all, we will initialize the priority queue. We will use priority queue here, and we initialize it to store the differences between adjacent heights with the maximum difference at the top. So priority queue is what we assign priority to each element, and according to that our top priority element is on top. So to store the difference between adjacent heights, we are using this, and with the maximum difference at which be at the top. And after that we will initialize variables I and diff to iterate through heights array and store the height difference between adjacent elements respectively. Now we will iterate through heights array from index 0 to h dot size minus 1, obviously, and after that we will calculate the height difference diff between the current and next elements. Then if the difference is less than or equal to 0, we will skip the next iteration, and if then we will subtract the height difference from the available bricks B. Then we push the height difference diff onto the priority queue, and if the available bricks B becomes negative and after subtraction, we will remove the maximum difference from the priority queue and add it back to B, and also decrement the number of available ladders. And if the number of available ladders becomes negative, we will terminate the loop, and after that we will return the index I, which represents the last successfully built step before running out of the bricks or ladders. So this is the approach we will follow for coding the solution. So let's take a look at what should be the code. And if you want more clarity, you can go through this approach again. So before going to the code, if you are new to the channel, hit the like button and subscribe for more content. So first of all, we will create a priority queue of integers. Let's define it as p. So we will create I variable and a diff variable, and diff is the difference for storing the difference, and I is the index we will return. Now we will iterate through for loop for int for I equals to 0, I less than h dot size. We will iterate through this for loop and I plus plus, and we will calculate the difference here. Difference is what? Height of I plus 1 minus height of I. And if this difference is less than equal to 0, we will continue. So after this statement, we will update b, and we will do b equals to b minus diff, and after that we will push to p, that is the difference, and we will check here a condition if b less than 0, then we will add b plus equals to p dot top. We will add p dot top to b and then pop out the p top value, and then we will decrement I. No, we will decrement L here, the L provided ladder. After that we will check if L is less than 0, and if it is true, then we will break from that loop, and at last we will return I, and I is the index, the farthest index that we can reach. So let's check the solution. Yeah, the solution ran successfully. Check for the unit test cases. So the solution is right. So talking about the time complexity here, it will be big O of n log n time, because for priority queue the internal sorting happens in n log n time, and we are using in big O of n for loop. So overall time complexity will be big O of n log n, and the space complexity will be big O of n, where n is the height of the total number of elements present in P. So that's it. If you enjoyed the video or found it helpful, don't forget to hit the like button and subscribe for more content, and also stay tuned for upcoming LeetCode problem of the day videos and exciting Monstack web development projects. Thank you.